Hi, I'm Cliff Neve, Director of Mad Maritime, and I'm excited to talk to you today about OT and ICS systems. Why should we pay special attention to industrial control systems? Well, because it frequently has a physical manifestation. Here's a picture of the Freeport Liquefying Natural Gas Facility. The Pipeline and Hazardous Materials Safety Administration found that there were deficiencies in the valves, and temperatures were increasing in a manner that the control systems couldn't handle. So if you can get access to those systems and impact temperatures or readings in the valves, you create a physical impact remotely. In light of Volt Typhoon and other nefarious actors, this is particularly frightening. So what is ICS? NIST defines industrial control systems as those that are used for specific tasks, like the ones mentioned here. It can also include SCADA systems, distributed control systems, as well as programmable logic controllers. We've been seeing a trend for decades for more automation in the maritime community. Just inventorying where these are can be a very complicated challenge within a very complicated port system. In maritime, there are a lot of different industrial control systems and OT systems that come into play. Ballasting on ships is normally monitored by a standalone system. Power management and RFID systems are usually connected in some way, shape, or form, even if just locally. Sometimes ships will create a VPN to a testing site on board the ship so that they're able to do testing while they're underway of how engines are performing, whether there's water in the oil and things like that. So again, more and more manufacturers are creating methods to do analysis while ships are underway. And then if you look at ports, you've got everything from pumps to cranes to camera systems. All of these systems are becoming more automated, digitized, and connected and need to be considered for cybersecurity threats and vulnerabilities. I want to address primary services, primary essential services, and here are some good examples of shipboard primary essential services. This comes from the American Bureau of Shipping, which is a class society, as part of their cyber safety program. The list talks about steering, propulsion, elevators, lighting, compressors, services that if they go down, whether from cyber or otherwise, can result in a very bad day on board a ship. So these are the services that you want to focus on from a safety perspective. One of the challenges in operational technology these days, as far as cyber goes, are standards. And the great thing about standards is there's so many to choose from. Complicating matters, no sooner is the ink dry on them than the next revision is coming, because threats are constantly changing, as are the capabilities, especially within OT systems. Those standards become tougher and tougher to address. There is no Patch Tuesday or similar thing like that to keep your systems regularly updated. NIST has their NIST 882 Revision 3, which is essentially an overlay to the NIST 853 controls for OT systems. The International Association of Class Societies has their standards. The International Maritime Organization has very high-level guidance and requirements on safety. And the Coast Guard recently came out with their proposed rule, which is several hundred pages that have already generated a lot of discussion, and that does include both IT and OT systems. Of note is that new ship construction may have different requirements from past ship construction. So those need to be taken into consideration as well as part of the new ship construction. A lot of these standards only address safety. They don't take data loss, PII, PHI, etc. into account, and they're only concerned about safety. So you have to blend sometimes your IT and OT standards in order to get a full cybersecurity scope. Now let's talk about challenges to securing operational technology systems in ports and on ships. The first is rotating personnel. That makes physical security a challenge as well as access controls. I've seen on both ships and in ports where usernames and passwords were prominently posted on the wall or on a sticky attached to a monitor. You have to account for the fact that people need to do their jobs, and obviously new people need to be processed through in a way that makes understanding access control and the importance of access control easy so that they don't bypass controls and post those usernames and passwords on the wall. Regarding multi-factor, some industrial control systems just don't provide any mechanism for multi-factor authentication or potentially any authentication at all. So if you have a physical access to the device, you own the device. In that case, physical security becomes very important. Firmware upgrades and software upgrades are also a challenge. Manufacturers push out firmware upgrades at random schedules, and it's difficult to stay up with them, and so frequently nobody does. They just let them be as they are, and as long as they're working, then the upgrade doesn't happen. Another huge one is supply chain, and that's one that was addressed in the executive order that came out from President Biden. A lot of these OT systems are manufactured in other countries, some of which are friendly to the United States, some that aren't. And whether it's a friendly country or not, everyone is in the cyber game to some degree these days. Making sure that you're getting equipment, cranes, pumps, and other systems from reputable sources is crucial. And then physical security is also a challenge. Terminals are big, ships are big, there's all sorts of folks coming and going. In some cases saying, hey, you can't from a network perspective impact this physical security is going to have to win the day. And we need to make sure that they're protected physically. The final one is what systems to monitor and what systems to not monitor. You have to balance the risk of introducing a connection for monitoring and making the device connected with a business or compliance reason to do so. So how do you overcome these challenges and where can you get help? The first is to conduct a comprehensive risk assessment tailored to your maritime environment. You should work with someone who understands maritime cybersecurity and is able to evaluate your environment in a manner that's appropriate to that environment. The second is 24/7, 365 monitoring of your IT systems so that you can see if OT systems are accidentally or purposely being connected, and to monitor any OT systems around the clock that need to be monitored properly for compliance or other reasons. Next is understanding how incident response works and planning in advance how you're going to handle certain types of incidents, who you're going to call, and how you're going to approach those. The time to figure that out isn't after an incident's occurred. It's understanding the if-then statements of what is going to happen and the actions that you're going to be taking when these incidents might occur. Next is segmentation assurance. It's really critical to ensure that all of your systems are segmented and compartmented as best as possible, that you can't access your IT systems from the camera systems, that you can't access your OT systems from your business computer, things like that. So segmentation assurance and doing penetration testing to make sure that that segmentation is properly implemented is absolutely crucial. Next are policies and procedures. Things like, how do you update your ECDIS, your electronic charting and display system? Do you connect that to the internet and let that just automatically download, or do you put a process in place where you use a secure USB and you keep the ECDIS system isolated and you do your downloads in a controlled fashion using USB? So sometimes policies and procedures and thinking through ways to more securely update your systems and keep them up to date is very important. The next is collaboration between your IT, OT, supply chain, local partners, and government and local agencies. Understanding how the ecosystem works together will help you with securing that system. Your contracting folks need to understand the importance of proper supply chain purchasing and considerations like that. The next is patching and upgrading firmware and software, making sure you have a proactive approach and that you're not just waiting for something to fail before you then upgrade it. Going through and seeing on an annual or semi-annual basis if there are new upgrades and patches that need to be affected to your systems is crucial. The next is physical security strategies, and this is one of the most important ones because if you're on a ship, if you have access to a device, normally you own that device. So sometimes only physical security carries the day. So understanding and posturing your environment for physical security is a critical consideration. The next is tabletop exercises to plan scenarios and do what ifs so that you know what to happen if a bad day occurs and how you would react. In cybersecurity, things happen in seconds, not minutes or hours. So the quicker that you can remediate a problem, the better off you're going to be. And in some cases, it makes the difference between success and failure. So exercising regularly your processes, your procedures, going through what if scenarios with professionals can be very helpful. And that's something that we can help with for sure. So feel free to reach out if you have any of those questions or if you want to talk about solutions to these big challenges. Thanks for watching, and I would encourage you to reach out to me if you have any questions or want to have any discussions about strategies whatsoever. I'm very personally invested in maritime cybersecurity. It's my passion, and it probably always will be. It's something I've been doing since 1989. So I'd be happy to talk to you about any questions you have or strategies that you are looking to employ for your maritime cybersecurity system. Thank you very much and have a great day.